Happy day students. So today is our third day, third class on waves. Yesterday we saw that what is the relation between velocity of wave and velocity of particle, and I explained you through various questions also. Now today we are going to see when we can say the wave is progressive and various other forms in which wave can be represented. Okay, so let us see first. So when we say that wave is progressive, a progressive wave means wave has velocity. Okay, when we can say wave has velocity, if I say that wave is written like v equal to a sine of kx minus omega t, this form, and in this form we say that velocity of wave is omega by k. So any equation which is represented in this form we can say is a progressive wave, okay, because it has velocity. Now this equation I could have written in another way also. It could have been a e to the power minus omega t plus kx also. This is also a form. Okay. Now in this form also this is a function of kx minus omega t, and here also we can say velocity is omega by k. Okay. The equation is y equal to a e to the power minus omega t plus kx. But if another way I write a wave equation like this, a log of e to the power omega t minus kx. Okay, now this is not a wave. This is not a wave. But this is a wave, this is a wave. Same way, another one, if I represent y equal to a tan kx minus omega, then this is also not a wave. Then in which case we can say wave is there. And if this form is there in kx minus omega t, we know that it has have velocity also, speed also. Okay, so first thing, how to identify which function is representing wave and which function is not representing a wave. So listen carefully. If we have a function which is defined for every value of x and t, that can represent a wave. Again, any function which is defined at every value of x and t, then that function can be represented as wave. Is that clear? So suppose our normal form like a sine of kx minus omega. Okay, now whatever value of x I am keeping, right from 0 to infinity, it is well defined. Okay, sine infinity is also there. Sine infinity also has value. Sine infinity basically means what? Very large value of angle. So you can say sine of 10,000 degree, 20,000 degree, 2 lakh degrees, 2.1 lakh degrees, 2 crore degrees. Everywhere sine is defined. Okay. Same way, whatever value of time I am going to keep, whether I am keeping 0 or I am keeping infinity, for every value of x and t, sine function is defined. Okay, or for that matter, if I have y equal to a e to the power minus kx minus omega t. Now suppose I keep x as 0 and t is also 0 at the same time, so that means this becomes 0, e to the power 0. E to the power 0 means 1. Okay. Now suppose here I keep x as infinity. So if x is infinity, kx minus omega t's value will become infinite. This will become e to the power minus infinity. See what's coming. That means this becomes a by e to the power infinity. Now e to the power infinity means infinite. Why? Because e is actually exponential factor and e to the power 1, its value is 2.7. So if you are going to do 2.7 to the power infinity, it will be infinity only. So this function will be defined. Its value will come as 0. Are you able to understand? If you are keeping here infinity, this value will become 0. And if you are keeping this as 0, x and t both are 0, it becomes e to the power 0 and its value will become 1. Okay, so this function is defined for every value of x and t. Sine is defined for every value of x and t. cos is defined for every value of x and t. So that's why they are all represented as wave. But if you take other functions, suppose tan theta, suppose I write like this. Other question, is it defined everywhere? If you take x equal to 0, t equal to 0, then y equal to a tan 0, it will become 0. Okay, defined. But if I take x equal to infinity, then it will become y equal to a tan infinity. Okay, or if I suppose I say x is equal to 90 or kx value is 90 and omega t is 0, then this will become y equal to a tan 90. Is it defined? No, its value is infinite. It is undefined. Here also undefined. Okay, and some other value also it can be undefined. So that's why, since tan theta is not defined for every value of x and t, this cannot be represented as wave function. Same way, log value also. If you have log value, writing like this, now we know that log of 0 is undefined. Okay, so that means if x and t both are 0, this will become undefined. So that's why log also cannot represent a wave. Okay, so what I told you, first of all we need to check whether a particular function is representing a wave or not. Okay, how to find it? We need to check it for every value of x and t, that function is well defined or not defined. Second thing, whichever the function is given, it must have this form. Which form? It must have this form, kx minus omega t form. If this form is there, then only we can say it's a progressive wave. It is having velocity. If this form is not given, then we cannot say the wave is progressive or not. Okay, for a progressive wave, this form, this phase is necessary. Okay, so if it is having, we can say this is a traveling wave. This method is good to know. Okay, if we know it, very good, because we can solve the problems very easily. But what is the effective way, or what are the ways given in the books? Okay, the condition given in books for progressive wave is something like this. I will write it. See now. If suppose I take a wave as a sine of kx minus omega t. Okay. Now we are going to differentiate it with respect to time. Okay, in last class also we did it. Again we are doing it. So see then, it's minus a omega cos kx minus omega t. Alright, one more time differentiation, that's d square y by dt square. Now what's going to come? Minus a omega will remain as it is. Cos will become minus sine kx minus omega t. Then differentiation of kx 0, minus omega t is differentiation, minus omega. So what we are getting? Minus a omega square sine of kx minus omega t. Okay, now differentiate this function again, now this time with respect to x. Once with respect to t, then with respect to x. So see what's coming here. Again, this we did in the last class also, that is ak cos kx minus omega t. One more time, so d square y by dx square. What's going to come now here? Ak, differentiation of cos minus sine of kx minus omega t. Then differentiation of this will be k, because t is constant here. We are differentiating it with respect to x, keeping t constant. We differentiate it with respect to t, keeping x constant. Is that okay? Fine. So this becomes minus ak square sine of kx minus omega t. Okay, now what we are going to find? Ratio. This divided by this. D square y by dt square by d square y by dx square we are going to do. You see what's coming. So d square y by dt square by d square y by dx square. Check what's coming here. This is minus a omega square cos of kx minus omega t by minus ak square cos of kx minus omega t. This and this gets cancelled. This minus is gone. This a is gone. Now take this one there. So d square y by dt square equal to omega square by k square means v square d square y by dx square. This is the condition of a progressive wave. If any progressive wave is there, it has to satisfy this relation. If it satisfies this relation, then only you can say that the wave is progressive or not. Okay, this is the method which is given in the books to you. But what I told you before, a smaller method, if any function is there which is well defined everywhere, its sign or e or something else, and it has a form of kx minus omega t, it means it's a progressive wave. That is how we will determine it, because we have to solve objective questions. Okay, but this is the effective wave which is given in the books. Is that okay? So there are certain questions which are based on this we will be solving right now. You see, question number 1 we will solve. First of all, it's given that this is a wave function, something like y equal to 4 by x minus 2t whole square plus 3. Okay, question is saying it's a wave function. So let us first determine whether it represents a wave or not. So first put it as, suppose at x equal to 0 and t equal to 0. Is it defined or not? Put x equal to 0, t equal to 0. What's coming? Y equal to 4 by 3. That means it has a value. Same way, if suppose this I say is infinity, if x minus 2t is equal to infinity. So if this is infinity, infinity plus 3 is infinity, 4 by infinity, that means 0. So at infinity also it is well defined, and at 0 also it is well defined. Okay, so that means it can represent a wave. Now we have to check, does it have the form of kx minus omega t or not? Check. So check it over here. Does it have or not? Yes, it have. Okay, so k value, if I compare this, k value is coming as 1 and omega is coming as 2. So what is speed of the wave? Omega by k, that means 2. Which direction is this wave moving? This wave is moving along positive x-axis. This wave is moving along positive x-axis. How can I say? I can say because here there is negative sign. If there was a positive sign there, I would have said that it is moving towards negative x-axis. Okay, is that clear? Let's see another question. And suppose question is like this. It says that wave is represented as y equal to 4 by x square plus 2. Okay, then the question asks us, write the wave function at t equal to 2 seconds. At t equal to 2 seconds, what will be this wave function? That's the question. Now, first thing is, we will be saying here there is no t form given. So we have to introduce it, then only we can say it's a wave. Is this function okay? Yes. Is this function okay? If x is infinity also it's defined, and if x is 0 also this is well defined. So yes, function is fine. So write the wave function at t equal to 2 seconds if wave is moving along positive x-axis. Now what to write? Y equal to 4. Now whenever wave is there, x and t should be together. Either it should be kx minus omega t, or it should be omega t minus kx. Okay, so here what to write? Here is x. So we will be writing x minus vt form. X minus 2t whole square plus 2. Okay, this is the wave at what time? 2 seconds. Is that clear? Wave velocity, write the wave function of at t equal to 2 seconds if x minus 2v whole square. Okay, because time is given 2 seconds. But if suppose the same function I say, write the wave function at time t when wave velocity is 2 meter per second, then this would have been written as 4 by x minus 2t whole square plus 2. Okay, here it's not t equal to 2 seconds. Here is wave function at time t. Wave function when speed, that's correct only, write the wave function at time t equal to 2 seconds. Correct only, because here t is we have written as 2 and v is unknown, so we have written it as x minus 2v, whereas here function is written in terms of t and velocity is given. So we have written the same function as x minus 2t whole square. Okay, same question is there in 2 different ways it is asked, so we have written also answer also in 2 ways. Here time was given, speed was not given. Here speed is given, time is not given. Is it okay?